Hello, and welcome to another stats warm up. All right, so this again is just going to be all about hypothesis testing, kind of going through the procedure, writing our conclusions, everything that goes into to completing one of these problems. So, in a recent year, 73% of first-year college students responding to a national survey identified being very well off financially as an important personal goal. State University finds that 132 out of 200 of its first year students say that this goal is important. Is there good evidence that the proportion of all first year students at this university who think being very well off financially is important differs from the national value of 73%? All right. So, first things first, because it just says differs from the national value, that tells us right there that we're going to be doing a not equal to test. All right. We're not doing a less than, we're not doing a greater than. We just want to know, does it differ from 73%? Now, if we look at the actual sample result, all right, we got 132 out of 200. So 132 divided by 200 is 66%. So the question is this sample result of 66% different enough from the established value of 73% that we can conclude that the state university has a different type of student that has different priorities? Or is this 66% sort of within the realm of random variation? All right. So we're going to start with our hypothesis. So our null is that P is equal to 0.73. Our alternative is going to be that it does not equal 0.73. All right, there's no compelling reason to use something different, so we're going to stick with our alpha of 0.05. Now, before you do this, you should, in theory, not in theory, you should go through and check your various conditions. So we are taking a random sample. The problem tells us that. We don't know how large the student body is at this university, but we're going to go with the assumption that 200 is less than 10%. And then we want to make sure we have at least 10 expected successes and 10 expected failures. And if we're looking at 73% of 200 or 27% of 200, both of those are over 10, so we're good to go. So we can now actually conduct the test. And again, we're going to do that on our calculator using the one prop Z test. All right. And this needs a variety of information. All right. First and foremost, it needs to know your null value. So for our problem, that's 0.73. All right. It needs to know your number of successes, which we're told is 132. It needs to know your sample size, which in our case is 200. And it needs to know what kind of test you're doing. And we're doing a two-tailed test because we're using the not equal to. So we can just say that we're picking not equal to p hat. All right, but that's just kind of showing me that you're setting up the problem correctly so that if something goes wrong later on, I can at least give you credit for the parts that you did correctly. All right, so if I hit calculate there, again, there's my sample proportion that we already kind of looked at there. There's my test statistic. So my test statistic is negative 2.23. And from that test statistic, we can figure out our p-value. And we get a p-value of 0.0258, we'll go with. All right. So this is basically saying, hey, if this is true, if the proportion is truly 73%, then you only had a 2.5% chance of getting a sample result this extreme or more. All right. So that's a pretty low percentage. All right. There was only a 2.5% chance of getting a result this extreme, assuming this is true. So given the low probability, we're kind of left to claim, all right, because our p-value is under 5%, which again is our alpha, we reject the null and accept the alternative. So basically we're saying, hey, what we found in our sample was far enough away from 0.73 that it's very unlikely that this is true for the college that we're looking at. All right. It seems that their students do have, differing priorities compared to the nation at large. All right, let's take a look at another one. University of Illinois did a study on aggressive behavior and surveyed a sample of 558 middle school students. When asked to describe their behavior in the last 30 days, 445 of them said it included physical aggression, social ridicule, teasing, name calling, or issuing threats. That's because middle schoolers are terrible, terrible people. Don't take that personally if you're a middle schooler. It's a rough time for a lot of people. This behavior was not defined as bullying in the questionnaire. Is this evidence that more than 3/4 of the students in the middle school engage in bullying behavior? All right, so basically what this is saying is, they didn't directly ask them, do you bully? They just asked them a whole bunch of questions that are essentially bullying to see the results that they got back. So again, we're going to set up a hypothesis test, and this one says, is this evidence that more than 3/4 of students engage in bullying behavior? So because it's saying more, this is going to be a one-tailed test, and we're going to look specifically for the greater than situation. So our null will be that p is still equal to 0.75. All right. The alternative will be that p is in fact greater than 0.75. Right? We're going to stick with our alpha of 0.05. All right. We still want to make sure that, our conditions are met. So we want to ensure that, there was randomization. We want to ensure that which they tell us, we want to know that our sample is less than 10% of the population. Again, that's going to be pretty easy to assume when we're only looking at 558 middle school students out of, however many. And then we want to make sure we have at least 10 successes and 10 failures, which again, 558 times 75% or 558 times 25% are still well over that threshold. So with those pieces in place, we can perform our one proportion z-test. This time our null is 0.75. The problem tells us that there were 445 successes. Again, success is relative there because we're talking about kids that were bullying. And then the sample size is 558. And this time we are testing to see if we are greater than the null. All right. So if we feed all of that into our stat tests, one prop z test, all right, 445, 558, and we're testing if we're greater than that. All right. We can see that our test statistic is 2.59. From that test statistic, we get a p-value of 0.0048. And again, our sample statistic was, 79, almost 80%. So this 445 that we got right here was about 80% of the students. So the question is, when you have a sample of 558 and 80% engage in bullying, is that far enough from this value of 75% that we can be pretty confident that the true value is actually higher? All right. Now, based on our p-value, we can, all right? Because our p-value is under 5%, which again is our alpha, we reject the null and accept the alternative. All right, so basically, we looked at the situation here, we gathered data. Our data said that 80%, engaged in some sort of bullying behavior. And based on our sample size, it was very unlikely that we would get that result. All right, there was a 0.0048% chance of getting this result or something more extreme, assuming that this was the true value. And since that probability is so low, we're kind of left saying, all right, this probably isn't the true value. All right, because if the true value is higher, then this sample might have been very likely. It might have been very common to get a sample like this. But if this is the true value, it's very unlikely to get a sample like this. So we're left to conclude that it's probably not the true value. All right, so again, this is sort of the process that you want to go through on one of these problems. Writing out the null and the alternative, stating your alpha, kind of showing me what you used, reporting the test statistic and the p-value, and then writing a conclusion based off that. All right, so let me know if you have any questions. Otherwise, best of luck. All right.